I told you that the sum total of all phenotypes in a given population is constant. So which we gave it by a algebraic equation. P square plus Q square plus 2PQ equals 1. So the factors which are going to change the Hardy-Weinberg equilibrium, factors which affect Hardy-Weinberg equilibrium are nearly 5 types were there. So first we discussed about gene migration or gene flow, genetic migration or gene flow. Then we discussed about genetic drift. The third one what we had discussed was mutation. Then we had also discussed about natural selection. So how is nature going to select that point? And apart from that, genetic recombination, which I have discussed in the previous class. Genetic recombination takes place during gametogenesis. What do you mean by gametogenesis? Formation of gametes or development of gametes. We call it as gametogenesis. It might be oogenesis or spermatogenesis. You might have studied in the first chapter. Okay. So you have to understand there is a drift. There is a moving away from Hardy-Weinberg equilibrium. Whenever Hardy-Weinberg equilibrium constant, that equilibrium is broken, it leads to evolution in that population. It can be because of any of these 5 factors. Now natural selection is also one of the factors. Natural selection, it has favoritism for certain phenotypes. And for a given condition, there is a phenotype which the natural selection prefers. So they have given a 3 graphs to study about how natural selection can affect a population. Natural selection can lead to stabilizing effect, or it can lead to directional changes, or it can lead to disruption, complete change of the mechanisms. So all these 3 values are there. Now the normal chart, graphical representation if we look into, so this is going to represent, the y-axis is going to represent number of individuals with phenotypes. Phenotypes I told you is the external character that an individual exhibits. We are not worried about genotype. So phenotype is external character. Now there is a graph showing mean character value is marked. Mean character value is nothing but phenotypes which are favored by natural selection. Phenotypes which are favored by natural selection. So they are partial to such phenotypes. Okay, favoritism is there. So now there are 3 types of it. Natural selection can lead to disruption in Hardy-Weinberg equilibrium based on it. It can have a stabilizing effect. How is the stabilizing effect seen? So the number of individuals with phenotypes, when you mark this graph, they have a peak which is higher, taller and narrower. So this sort of graph indicates natural selection is having a stabilizing effect on the population. In the second graph we can see this is the mean character value, isn't it? So there is a directional move away from the mean character value. So natural selection is preferring the mean character value with the away. There is a directional move. There are other phenotypes which are more dominant than the natural selection preferred phenotype. So there is a directional change. And you can see that the peak shifts to one direction. There is more shift towards this direction when you look into the graph. Okay? And the natural selection has a disruptive effect where you can find 2 mean character values of the curve. On the curve, you have 2 mean character values and they are moving away in opposite direction. So this leads to a disruptive change in the population. So this is the effect of natural selection on a given population. It can have a stabilizing effect, that is, it prefers has more individuals with mean character value, or it can move away from in one direction, away from the mean character value. We call it as directional change. If it leads to 2 opposite directional changes, so it is disruption of that phenotype in that population. We call it as disruptive natural selection. So these are the three types that you have to remember that the natural selection has an effect on. Whenever they ask you factors affecting hardy-Weaver equilibrium, you have to draw this and explain the natural selection process. See, natural selection is working in tandem with other things like genetic migration, gene flow, genetic recombination, mutation, and it is working in coordination with them. It is not working all alone. And they are nature selects the best phenotype. And they are going to increase in numbers through reproduction of that phenotype. And there will be a population having only those phenotypes which are favorable. So this is how the hardy-Weaver equilibrium gets affected.